Hello, my name is Caitlin Armstrong. I have the pleasure of representing New Mexico Tech's EE department. I did not do this project alone. I worked with 3 other people, Levi Dryden, Jared McDonald, and Riley Myers. Our project was sponsored by Omnius Tech. It is Care Companion. Omnius Tech was inspired to start this project when they recognized a lack in the medical field, that individuals living alone were receiving poor quality of care, they were having longer recoveries, and it cost more every time they fell. So our sponsor was inspired to create this project, the goal of which is to have an automatic fall detection and alert system. We approached this problem using millimeter wave radar, which is a really powerful tool that returns time of flight as well as Doppler velocity data, which we are able to use to discern when people are moving with coordination and when they aren't. The basis of our design is to have a millimeter wave radar in every room that we would use to track individuals in a space. We would relay that information to a central computer only when there is an alert, and this way we would be able to protect people's private information. To determine when someone has fallen, we are taking a standard deviation of Doppler velocity over time. And what we found was that when people are walking, you don't see much variation. You have this very nice and consistent graph on top, and you see that it doesn't really spike over 1 at all. On the contrary, when people are falling, there is a deviation upwards of 1, and that is what we're using to determine when someone has fallen or not. A more interesting part of the project, I think, was that we also characterized the activity level, the duration of activity, the time of activity, and where activity is placed. And by mapping these features, we're able to create a habit tracking log using clustering algorithms. And in this way, we would be able to create alerts when people are using the bathroom too frequently, when they've slept for far too long, when they're suddenly become manic, we'd be able to report that all to a caretaker automatically. In addition, we also generated our own novel simulation that we used to test the algorithms. Are there any questions? Yes.
It seems like in addition to the fall detection, you can detect whether somebody hadn't gotten up for longer than what would you expect? Exactly.
That was a focus that our sponsors had for the design. They wanted the fall detection alert system, but they also recognized that there are all kinds of behaviors that can happen when you're living alone that might become dangerous. So if someone's manic, if someone's not sleeping, if someone's not eating, we want to be able to recognize that and report it immediately, because sometimes patients won't or can't. And so that is, what we're tracking.
Could it also detect whether a second individual had come in, so if you had an intruder or something?
Yeah. Yes.
Could you detect near misses or stumbles or?
Yeah, in fact, we categorize the level of falls. So from a very low severity fall to a very high severity fall, we're able to tell the difference.
Can you do vital signs detection with this?
As a matter of fact, yes. The sensor we picked, the sensor that we used in our design, is not the best option for that, but there are other millimeter wave sensors that are tuned specifically so that they can measure respiration and heart rate, and so there is a huge potential to apply that to this problem as well. Yes.
So the system would bathe the subject in radar 24/7. Did you consider the marketability of such a thing?
So the marketability. When our sponsors did interviews with seniors in a living home, what they found was that no one wanted wearables. No one wanted the Apple Watch. Like they just didn't want to put it on, even though that is a really great way to tell when someone has fallen or when someone is moving or when someone's heart rate is spiking. And they don't want cameras in their home. So the millimeter wave radar was a really uninvasive way to track this. There's no image at all. You just get the time of flight and the Doppler velocity data, and by filtering that, you're able to determine how much they're moving, where they're moving to. Yeah. Yes?
So what about for a lot of times people start being unsteady?
Yes.
Are you able to see those motions as they're walking abnormally or tottering, if you will?
That's a great point. So ideally that we would be able to predict. That isn't something that we achieved. We were able to determine if a fall had happened. With more machine learning applied, I think that we really could predict it. I think we could do HMM. A hidden Markov method, I think, is the most powerful one for that particular predicting when a fall is going to happen.
What do you estimate the cost to install, let's say, one run would be?
So the sensor on its own is only $40 or $50. And with a computer on board, it would be less than $1,000 to install in a home. All right, thank you.